Alright, so I'm going to be talking about where deltas can come from in the context of client-server. And today we're going to be talking about how missed packets cause deltas, and missed packets are the only reason we use client prediction and server reconciliation. Because if the client and server were both perfectly synchronized and both were deterministic, we could guarantee that the client state would be the same as the server state. So, the reason why lost packets throw a wrench in this is going to be as follows. So, first of all, we have some error going on. So, we see on line 64,972, we have this delta. And this is after reconciling our physics state, e.g. position and velocity. So let's go figure out why this is the case. So go to my client logs. Client logs. And then 64978. So 64978. Alright, so here's that error we were looking at. And why did this error happen? So as you know, in the reconciliation algorithm, an error can only happen if the set state at the start, the authoritative state we set at the start of reconciliation was different from the actively, how do I say that? So I guess maybe I'll use paint again, but I won't go too in depth. So I'm just gonna paint the whole thing black and then use white on this. Okay, so what's going on here? So when we reconciled, what did we do? So we actively had some state and some stuff going on, and we received like this authoritative state from the server, and it said our position after processing a certain state update data was this. And so when we slam it in right here, we're going to reapply these inputs on top. So if there's a delta, the delta exists because the slammed in state did not equal whatever state should have been there, which was like produced on the client. So this would have been like our predicted state. And our predicted state equals to the state produced here. And this was before reconciliation, there would have been another reconciliation that had come before. And there would have been an authoritative state that was slammed in here. And then we would have reapplied some inputs on top of it. And then after that happens, we have another input that was processed here. And it happened after these. So it's on top of the reconciled state. And what happens is, so say we got all the way out to here, then we go here, we apply it, and then we redo it, right? So if this is different than what came in, then it means that what was processed on the client was different than what was like processed on the server. So if like we had labeled each one of these, the sequence of inputs processed on the client was not the same as the ones on the server. And the only reason that can happen is because a packet is lost. because theoretically in our current setup, we send out every single input update to the server. So they should all get there unless like the packet gets dropped. So that is high level way of describing it. I didn't want to do an in-depth detail right now. I've done that elsewhere, but pretty much now I'm going to show that that's happening here. So the last state update data ID used to update this was 788, right? And so what does this mean? This means this was the last SUD. I'm going to call a state update data a SUD. That was the last SUD used on the server to produce this state, right? Okay, fair enough. So on the previous reconciliation, the last SUD used should be 777, right? So start reconcile. Okay, so the previous one for physics was 776. So we're missing 777. So one thing I was thinking of was like, what if it was like there was two periodic things happening and like one managed to slip in twice during a signal? So that was an idea I had. And the way I confirmed this was not true was whenever I send it out, I type just sent client input packet. So here we can see this one has 782, so we need to go back a bit. 781, 780, 779, 778, 777, 776. So we send out sequential ones, right? So we even saw that we sent out 777, which is right here. But on the server, we have this. So this is just received client input packet 776. But do we ever receive client input packet 777? So if we go to the just received client input, the next one is 778. So we never receive 777. And fundamentally, that's going to cause an issue because the client state will have that update and the servers won't have that update, which will create a delta. So this is just to prove that like having a delta will happen. Like if a packet just doesn't get there, a delta will be produced. And without client reconciliation and without client prediction server reconciliation, that error cannot build up. It's capped off. And that's why it's needed, for no other reason than that. I mean, there are other reasons, but this is one reason that proves it's required. Because deltas do exist, and so you have to correct for that, because if the server didn't do it, then you need to account for that in your own prediction so that your prediction doesn't stray off too far. And I guess it's just fun. Now that like I've demonstrated it, I may as well show you that like this error isn't that bad. So I'm actually going to delete this right now. So here we're going to just launch the server and we're going to launch a client. And I'm recording, so it might feel a little bit laggy, but I can tell you that this does not feel bad. Like, there's definitely some times when packets aren't going to make it, but I'm just saying, as of right now, I don't think I feel that. Other than like recording, maybe jitter or something, which I don't really feel. I just feel like this is pretty regular. It feels fine. So this is just to show that like, you know, this whole, it's okay to have deltas Obviously you want to minimize them as much as possible, but for the most part, some of them are guaranteed to occur just due to packet loss, and you will have it. And that's about it.